All right. So if you remember in the previous class, I could not take because of some health issues. So briefly before that, we completed ellipse and we did everything, especially the tangent and normal portion, which you have never done before. So ellipse has already been done. Hyperbola is almost on the same page. All right. So today we'll start with hyperbola and we'll try to get over as much as we can. Got it? So here the main thing that we are going to do is definition, then equation, then tracing of hyperbola. Got it? Then conjugate hyperbola, parametric equation of a hyperbola, and position of a point also we'll discuss. Then line and a hyperbola, either it is a tangent or it is a normal or it is just passing through, it is neither touching nor intersecting. And then finally, we'll discuss more about the tangent of the hyperbola. All right. Now, if you remember, in the definition of conic section, I told you locus of a point which is moving in such a way that the ratio of its distance from a fixed point and from a fixed line is always constant. Locus of a point which is moving in such a way that the ratio of its distance from a fixed point and from a fixed line is always constant, then that locus is called conic. Now, if this constant ratio is called, I told you, eccentricity. Yes or no? This constant ratio is what we call eccentricity. Just a moment. Just a moment. Just a moment, students. Just a moment, students. It will take me a while. My Apple Pencil is not working. Just a moment. Just 1 minute, students. It's still not working. Hello, am I audible? First of all, just let me know if my voice is visible to audible to you and my video is visible to you. All right, thank you so much. See, students, my pencil is not working today, so I might not be able to write everything. All right, so but I'll try to discuss as many things as possible with you. So better do one thing. Let us revise ellipse today once again. And we'll go through the entire ellipse section. So there's no point of doing hyperbola because the pencil is not working. So ellipse was what? It is the locus of a point. It is the locus of a point which is moving in such a way, which is ellipse is the locus of a point which is moving in such a way that the ratio of its distance from a fixed point to a fixed line to a fixed line is always constant. Ellipse is the locus of a point which is moving in such a way that the ratio of its distance from a fixed point and a fixed line is always constant. This fixed point is what we call focus. This fixed line is what we call directrix. All right. So in that case, this PS upon PM comes E. Point, distance of point H comma K from a fixed point upon distance from a fixed line is PM. So PS upon PM is E. Now this E is fixed for a particular conic. This E is what we call eccentricity. If this eccentricity is equal to 1, this conic is parabola. If this eccentricity is less than 1, this conic is ellipse. And if this eccentricity is more than 1, this conic is hyperbola. All right. So this was the definition. Once again, I repeat, locus of a point which moves in a plane in such a way that its distance from a fixed point is in constant ratio to its distance from a fixed line. Got it? Now, general equation of the ellipse is simply what? If the fixed point is say, which is focus, is say h comma k, this fixed line, which is what we call directrix, let it is ax plus by plus c equal to 0. Then the eccentricity E is given by x minus h whole square plus y minus k whole square is equals to eccentricity square multiplied by distance of this point x comma y from this line ax plus by plus c, square of that. Am I clear? So if we simplify this entire equation, so we get a second degree general equation. That second degree general equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Got it? That is equation in x and y, and this equation will represent an ellipse if h square minus ab is less than 0 and this delta is abc plus 2fgh minus af square minus bg square minus ch square is not equal to 0. Am I clear? ABC, FGH. This is what? ABC plus 2FGH minus AF square minus BG square minus CH square is not equal to 0. Got it? So this is the general equation of an ellipse. Now, if I come to standard equation, of the ellipse, see that standard equation is, now let us consider that fixed point is AE comma 0. Got it? That fixed point is AE comma 0 and this fixed line is x equals to A upon E. Got it? So in that case, if I assume this fixed point P as h comma k, then PS is equals to PM if you apply. You get this equation. H minus AE square plus K square under root is E times A upon E minus H mod. That is A minus EH. Now squaring both sides, we get x square upon A square plus y square upon A square into 1 minus E square equals to 1. Got it? Now, if I call this A square into 1 minus E square as 1, so this E comes out to be under root of 1 minus A square upon B square. This E comes out to be under root of 1 minus A square upon B square. Got it? So the standard equation became x square upon A square plus y square upon B square is equals to 1. Have I made my point clear? So the standard equation became x square upon A square plus y square upon B square equals to 1. Now this is the general shape of the ellipse. In the previous lecture, you must have seen how did we draw it. Now, since there is x square, means replacing y by minus y, the equation does not change. That means what? If replacing y by minus y, the equation does not change, that means this equation is symmetric about the y-axis. Now replacing x by minus y by minus y equation does not change, means symmetric about x-axis. Replacing x by minus x equation does not change, means symmetric about y-axis. So this ellipse equation is going to be symmetric about x-axis and y-axis. That means if there will be a focus A comma 0, which I assumed, there will also be another focus minus AE comma 0. Got it? If there is a directrix x equals to A upon E, there is also another directrix, that is x equals to minus A upon E. Understood? So in that case, eccentricity is this AA dash, sorry, this equation of ellipse intersect x-axis at A comma 0 and minus A comma 0. At A comma 0 and minus A comma 0, they are called the ends of the major axis. Now this B comma 0 comma B 0 comma minus B, these are called ends of the minor axis. So length of major axis is what we call 2A. Length of minor axis is 2B. Eccentricity E is under root of 1 minus B square upon A square. That is 1 minus minor upon major whole square. Am I clear? Now various terms related to the ellipse. Let's go through them also. Vertex of the ellipse. Points at which the ellipse cut the x-axis, A comma 0 and minus A comma 0 are called vertices of the uh, please can you speak with the mic? Thank you. So the points at which this ellipse cuts the x-axis, A comma 0 and minus A comma 0 are called the vertices of the ellipse. Now, major and minor axis, the line segment AA dash is what I told you is the major axis. BB dash is what I told you is the minor axis. Length of major axis is 2A and length of minor axis is 2B. Center is 0, 0. So this is what you are already aware of. Now directrix x equals to A by E and x equals to minus A by E. Focus is AE comma 0 minus AE comma 0 are the two foci. Latus rectum of the ellipse, that is latus rectum is everywhere same, line perpendicular to the major axis and line perpendicular to the major axis passing through the focus. So in case of ellipse, length of latus rectum is 2b square upon a, and this is simply you can achieve in the equation of ellipse x square by a square plus y square by b square equals to 1. If you replace x by a, if I replace x by AE, then the y coordinate you get as b square upon a plus minus b square upon a. Got it? So length of latus rectum is 2b square upon a. Am I clear? Now have a look at this small question. Length of latus rectum is 1/4 of the length of the minor axis. Length of the latus rectum is 1 by 4 the length of the minor axis. Then find the eccentricity. Yes, how to do? Give it a try. Solution is also there. You can have a reference. Just a moment. Actually, I don't understand what happened today with the iPad. Yeah, we have to continue with this only. Now see, there is a focal distance property of the ellipse. So according to this focal distance property, PS1, PS1 is what? PS1 is E times PM1. Distance from the focus is E times distance from the directrix. So PS1 is E times PM1 and PM1 is what? PM1 is, if you see in the diagram, it is total A upon E, distance between y-axis and directrix minus H. A upon E minus H. So PS1 is E times A upon E minus H. That is A minus EH. And PS2 is E times PM2. PM2 is E times H plus A upon E. So PS2 is A plus EH. So if I add both of them, so this is what we call focal distance property of the ellipse, that is PS1 plus PS2 is equals to 2A. PS1 plus PS2 is equals to 2A. Am I correct? So PS1 plus PS2 is equals to 2A. And now see, if you realize this distance between S1 and S2, distance between S1 and S2 is what? 2AE. And E is less than 1 in case of ellipse. So distance between the foci is 2AE, that is S1, S2, and PS1 plus PS2, that is the length of the major axis. So PS1 plus PS2 is length of the major axis. Got it? Now, these are the simple questions. Focal distance property. See, this is a very amazing question. two given circles, it should be circles, not ellipse. So two given circles with centers as S1 and S2, radius R1 and R2 are such that they lies completely inside, that one lies completely inside the other one. So two given circles with centers as S1 and S2, radius R1 and R2 are there, and one lies completely inside the other one, and they are non-concentric also. Non-concentric also. Got it? And another moving circle, or I should say variable circle, is touching both of them. Find the locus of its center. Touching both of them, find the locus of its center. Now, if you see, there are two red circles, one inside the other one having, I assume, center as S1, other having center as S2. Now, there is another green circle you see, which is touching both of them. Definitely, if it is touching both of them, it will touch one of the circles internally and other circles externally. So, it is touching both of them. Now, what do you have to say about the distance CS1? CS1 is what? Radius of the larger circle minus radius of the assumed circle, that is R1 minus R. Got it? And then there comes CS2. CS2 will be what? CS2 is R2 minus R. Am I clear? So CS1 is R1 minus R. CS2 is R2 plus R. So what is the CS1 plus CS2? CS1 plus CS2 is equal to R1 plus R2. CS1 plus CS2 is R1 plus R2. So locus of the point, locus of the center of the circle C will be what? That will be an ellipse, because this point C is moving in such a way that the sum of its distance from two fixed points S1 and S2 is always constant, R1 plus R2, and this is more than the distance between C1, S1, S2, that is what? Less than even R1 minus R2. Am I clear? So locus of this point C will be an ellipse. Now, parametric equation of the ellipse. So if this is an ellipse, see here, what is auxiliary circle and what is eccentric angle? A circle described on the major axis as diameter is called auxiliary circle. A circle described on the major axis as diameter is called auxiliary circle. So a circle described on the major axis as diameter is called auxiliary circle. So in this case, auxiliary circle will be x square plus y square is equals to a square. Auxiliary circle will be x square plus y square is equals to a square. Got it? And now eccentric angle. Eccentric angle is what? If we take any point on the ellipse, if I take any point on the ellipse, that is a cos theta, b sin theta. Got it? If I take any point on the ellipse, a cos theta, b sin theta, then just a minute. Thank you so much, students. Now the pencil is working. So see, ellipse we have already covered. I was just trying to recall since my pencil was not working and I was not able to write anything. So now let's start with hyperbola. Got it? So initially the hyperbola is moreover same as it is ellipse. So hyperbola is defined as the locus of a point which is moving in a plane. Hyperbola is defined as the locus of a point which is moving in a plane in such a way that the ratio of its distance from a fixed point and from a fixed line is always constant. Now you must be considering, few minutes back I was telling the same definition for the ellipse, and I have told you the same definition for the parabola also. But remember, this ratio of constant PS upon PM is different in all three cases. Here, since this ratio eccentricity is greater than 1. So we call this locus of point P as directrix. Since this ratio is more than 1, we will call it as directrix. Am I clear? Fair enough? Now, let's derive the standard equation of hyperbola. So, standard equation of hyperbola. Now, what according to the standard equation? If I take one focus as AE, if I take one focus as AE, comma 0, and one directrix as x equals to A upon E. Got it? Now there is a point P, H comma K, which is moving in such a way that PS, distance from this fixed point, and this PM, distance from this fixed line, such that this PS upon PM is constant. E. Got it? Now, what will be PS? PS is H minus AE square plus K square under root upon PM, distance of P from this. Now, if you realize this full distance is H and this distance is A upon E. So, PM is what? H minus A upon E mod is equals to E. So, it is under root of H minus AE square plus K square is HE minus A mod. Now, if I square both the sides, it will be H minus AE square plus K square is HE minus A whole square. Am I clear? Now simplify, this will be H square plus A square E square minus 2AEH plus K square is A square plus H square E square minus 2AEH. This 2AEH cancelled. Understood? So this 2AEH cancelled. So it is H square into 1 minus E square plus K square is A square into 1 minus E square. But there is one thing to notice. That one thing to notice is E is already more than 1. In case of hyperbola, this eccentricity is more than 1. That means this 1 minus E square is going to be less than 0. Got it? So I am going to use it as E square minus 1, which will be positive. So it will become H square upon A square plus K square upon A square into I use it 1 minus E square as E square minus 1 with a negative sign. And this is equals to 1. Correct? So, what will be the locus? Locus is x square upon A square minus y square upon A square into E square minus 1 is equals to 1. So, finally your locus is, if I assume A square into E square minus 1 as B square, so your locus eccentricity is under root of 1 plus B square upon A square. Correct? And equation of hyperbola is x square upon a square minus y square upon b square is equals to 1. Got it? X square upon a square minus y square upon b square is equals to 1. Have a look. Now, if I go for its tracing, if I think of tracing this hyperbola, this is going to be the trace of the hyperbola. See, this is going to be the x-axis on which you have assumed focus. This is going to be y-axis. Now see, there is one focus which we have assumed AE comma 0. Again, in the equation of this hyperbola, replacing x by minus x equation does not change. Replacing y by minus y equation does not change. That means this hyperbola is symmetric about the x-axis as well as about the y-axis. That means if one focus I assumed as AE comma 0, it has another focus minus AE comma 0. If one directrix I assumed as x equals to a upon e, it has another directrix x equals to minus a upon e. This hyperbola will be intersecting x-axis at a comma 0. A comma 0. And intersecting x-axis again at minus a comma 0. So this point is what I call ends of transverse axis. Transverse axis is what? This is what we call transverse axis. Transverse axis. Transverse axis is the line on which both the focus lies. Transverse axis is the line on which both the focus lie. And this y is what we call conjugate axis. Conjugate axis is where the hyperbola does not meet. Got it? It can be y-axis, it can be x-axis. So now, like in this equation, if I put x equals to 0, I get y square equal to minus b square. That means there is no intersection with the y-axis because y square cannot be minus b square. So this is the standard shape of the hyperbola. This kind of shape. Am I clear? This is the shape of the hyperbola. It is symmetric about the y-axis also. Understood? Now x is equals to a by e, one directrix, x equals to minus a by e, another directrix. Now, like there was a property in the ellipse also, PS1 plus PS2 is equals to 2a. There is also a focal distance property in hyperbola. See, what is say there is a point P on the hyperbola. I'm using the blue pen. There is a point P on the hyperbola. What is this distance PS1? PS1 is E times P say this is PS, not PS1. So PS is equals to E times PM. So that will be what? E times. Now, if this point P is H comma K, what is PM? PM is going to be H minus A upon E. So H E minus A. And PS dash is E times PM dash. That is E times H plus A upon E. That is HE plus A. Now, if I subtract both of them, that is PS dash minus PS, what are you going to get? You are going to get 2A. Got it? Now, this P point can be on the left branch of the hyperbola. So, I'm directly taking modulus of this. So, PS1 plus PS2, PS1 minus PS2 mod is equals to 2A. This is the focal distance property of the hyperbola. That means it is the locus of a point which is moving in such a way. Locus of a point which is moving in such a way that the difference of its distances from two fixed points S1 and S2 or S or S dash is always constant. And this constant 2A is less than the difference between fixed point. This constant is less than the distance between fixed points. So this is a very, very important definition. That is, locus of a point which is moving in such a way that the difference of its distances from two fixed points is always constant. And this constant is less than the distance between fixed points. So locus of a point which is moving in such a way that the difference of its distances from two fixed points is always constant, and this constant is less than the distance between fixed points. Am I clear? Is called hyperbola. Now these fixed points is what? These fixed points are foci or focus, and this fixed distance is called length of transverse axis. Length of transverse axis. Got it? Like, see, there's a question also on this. Right now, I made you remember a question on the ellipse where two circles are like that. One is inside the other one. Now, there's another question. Two fixed circles are such that they are distant from each other. Distance from each other. The situation is something like this. One circle here and another circle here. Got it? Now another circle touches both of them externally. Another circle touches both of them externally. And this is a variable circle. Another circle touches both of them externally. Even I should say another variable circle touches both of them externally. Find the locus of the center of this fixed circle. Sorry, of this moving circle or variable circle. Now see, this is the center C, which is a moving circle. This is first given circle, say S1. Its radius is R1. This is second circle CS2 with center and its radius is R2. Let us assume this moving circle has radius R. Now what is CS1? CS1 is R plus R1. What is CS2? CS2 is R plus R2. Got it? Now if I do CS1 minus CS2, this is going to be what? R1 minus R2. Am I clear? So CS1 minus CS2 is going to be R1 minus R2. That means a fixed point C, a variable point C is moving in such a way that the difference of its distance from two fixed points S1 and S2 is always constant because both of these values are known to you. Is always constant, and this R1 minus R2 is definitely less than this R1 minus R2 is definitely less than S1 S2. So locus of C is a hyperbola. Got it? All right, students. So because of my pencil breakdown, this class has been a chaos in the beginning of first like half an hour, I think. So in the next class, we'll continue with the hyperbola only. And you make sure you revise it on your own and also take a like constant revision of ellipse also. All right.